Alright, this is a screencast explanation of a problem that we looked at in class, and the genre of problems that we're in is grouping objects together. So one thing that you can always do in problems like this is draw a free body diagram of one object, then a free body diagram of the other object. Each free body diagram gives you an algebra equation, and you can solve a system of equations. But this screencast is going to be about a quicker way to solve the problem, and that's by treating them as a system. I know that I can treat them as a system because their accelerations are the same. Their accelerations are the same because if they weren't the same, the string would break or the string would go slack, and that's not what's going to happen in this situation. So I've got an applied force of 24 newtons that's being applied on this string to the right, and then there's also a string connecting this 2 kilogram and this 1 kilogram object. So if I draw a free body diagram of the system, I call it the mass of the system there, then what are some forces acting on the system? Well, if the system is these two objects together, there's only one force acting on the system. It's this force of 24 newtons to the right. So now I can make a Newton's second law statement about the system. The acceleration of the system is equal to the combination of forces on the system acting on the mass of the system. There's only the 24 Newton force acting on, what's the whole mass of the system? Well, it's 2 plus 1, it's 3 kilograms. So that means that the acceleration of the system is 8 meters per second squared. So that's the answer to the first part. That's the acceleration. That was part A. B, what's the force of tension between the boxes? I'm going to now change my color and look just at one of the objects. The force of tension is not a force that acts on the system. It's not this force of tension between the two boxes wasn't something that I drew into this free body diagram. So looking at the system can't help me find it. I can draw a free body diagram of the 2 kilogram block and say, what are the forces acting on the 2 kilogram block? Well, there's only the tension force pulling it to the right because there's no friction. And that's it. So the acceleration of this 2 kilogram block, comes from the combination of forces acting on it divided by the mass of it. And that's equal to, I guess, this force of tension, and that's what we're trying to solve for, divided by, what's the mass? It's 2 kilograms. Now we already solved for the acceleration. We know that this is 8 meters per second squared. Hold on a sec, I'm doing a screencast! So the force of tension is, I'll just solve this equation for the Ft. So the force of tension is 2 kilograms times 8 meters per second squared. That's 16 newtons. So what did we do? We found the acceleration quickly by looking at the whole system and the one force that acts on it. Then we found the force of tension on that is exerted by the string on this block. Also, the same force of tension is exerted by the string on this block. We found that by drawing a free body diagram of just the one block, naming the forces that act on it, and solving quickly. Could I have instead, for part B, looked at the 1 kilogram block and drawn a free body diagram for it? Yes, I could have. It would have been a little more complicated, but it would have worked too.